Welcome to Energy Talks, a regular podcast series with expert discussions on power system testing topics. My name is Scott Williams from the podcast team at OMICRON, and I will be your host. In this episode, we are going to talk about the challenges being faced by a changing power grid. These challenges are influencing work practices and priorities not only now, but also into the future. What are these challenges, and how can they best be mastered? With me to talk more about this topic is Florian Fink. He is a product manager at OMICRON who specializes in the area of industrialization and distribution. He also has many years of experience in field testing, especially with OMICRON's CMC test set, and he has also conducted research to identify factors driving change in the power grid. Hello, Florian. Welcome to Energy Talks.
Hello, Scott. Great to be here.
Florian, tell us about the type of research you conducted.
So in the power grid, there is so much going on, especially in the medium voltage area or low voltage area, due to all the challenges we are facing here with decarbonization and so on. And we would like to uncover a little bit of the mystery, what's happening there. So having a look into the grid and what our customer are doing there. There are so many buzzwords like microgrids and so on. And yeah, we would like to see what's really happening in the grid, talking with our customer and trying to help them.
Very good. And we'll be talking more about this in this episode. Florian, what excites you most about working in the power industry?
So for me, it's always fascinating, the power of electricity. It's at its own. So when the journey started 100 years ago with the first machines and all the power it now gives us driving all the electricity, starting from heating over now electric cars, light, very simple but very powerful, and making this available for everybody, that's a big advantage we have nowadays.
Florian, as the product manager for industrial and distribution applications at OMICRON, what are the factors you see leading to changes in the power grid?
So we see there at the moment big changes, mostly due to the terms decarbonization or energy transition. So what is happening there? We have changes due to the decarbonization in the transport sector, in the power generation sector, in the heating sector, and also industries are changing their production. For example, steel and also others try to decarbonize and bringing more power coming from renewable energies into their grid. So we see more electricity demand and new tasks for the power grid and the utilities.
Okay, Florian, what are the consequences for the power grid now and into the future?
So as we are switching more to renewables, we see less big power plants, which are changing the structure of the grid, which was established last years. Vary. So we have changing load flows in the power grid, as we had in the past, right all the way down from the big power plants through the transmission distribution sector down to the households or the industries. And now we have also, that the households itself have PV installations. Industries have their own smaller power generation. So this changing the load flow totally. Due to that, we have much more redispatching in the high voltage area. So due to all the changing load flow, the generations we have coming from, for example, offshore wind farms or PV installations. So sun is shining different or only on the day. Wind is coming on different times, and therefore we have to handle that in the power grid. And the transmission of the DER energy will happen also on the electrical way, but there is also going with power to gas, so transmitting this energy also via gas.
Okay, just to clarify, what is DER energy?
DER is distributed energy resources, so it's a typical term used for the PV, photovoltaic, wind energy, gas, and also also renewables. There are big power plants, like I mentioned already, offshore wind farms, but also a small installation on a household with maybe 5 kilowatts.
Florian, how are these challenges handled by the industry?
So what we see at the moment, there are grid expansions on all voltage levels. So we see there massive investments into the grid to handle these upcoming new energy needs on two different levels. And what we also see is that we see the digitalization of the substations on all levels. So we see there an increase of control to make these substations more and more smart, and that they get automated to make it easier to control. On the other hand, of course, it's also very difficult for the workforce itself. So we see also the workforce management, because the workforce get more and more complex tasks to do, and therefore it must be handled as good as possible. And what is also happening, and it's one of the largest investments, is that the distribution grid is getting smarter. So the distribution grid is one key element where the load flow is changing domestically. And there, at the last years, it was more or less a blind spot for the distribution utilities. What is exactly the load flow in the distribution grid? Here are more and more sensors are installed. These sensors sending up the data to the SCADA or control center, so that the utilities can better do planning or adjust the load flow here. And also what's happening here, the interaction with prosumers.
Interesting. That's an interesting term. Florian, tell us about prosumers.
So, as you might know, in the past, a normal household was just passive. It was consuming the energy for cooking and all the other stuff. But what's happening now, we have a solar installation on the rooftop. We have a heat pump for the heating, and maybe also an electrical car. Or also a battery inside of a household. So these are all stuff which is available right now, and such a household is now an active component in the power grid, not only passive consuming. It can deliver energy to the power grid. It can store energy on the heating sector, or also in the battery or the car itself. And here, of course, it's a key element to interact with these prosumers to make the power grid stable, so we can save energy in critical situations, or the prosumer can help to stabilize the grid with these interactions.
Interesting. So just a quick question about that. If I am generating my own energy at home, am I also supplying some of this energy to the power grid?
Yes, of course, it depends on the distribution utilities, and it's their decision. But in many countries, this is possible. So with your solar installation, you can also feed into the power grid, and and maybe an industry which is producing can use these energy.
Florian, are there any new types of measurements or diagnostic equipment required, or are current measurement methods and devices able to cope with the challenges the grid is facing?
So as I mentioned before, what is happening in the substation that they are getting digitalized. Digital tools are getting more and more important. So, for example, this communication standard IEC 61850 is coming to the substations, and there we need new tools. For example, in the past, a technician or engineer could easily measure the secondary voltage of a voltage transformer just with a multimeter. Now we are talking about sampled values, and therefore you need a visualization, a tool, and also a device to make these values again visual. Another thing is to continue with the lifetime of assets. So in principle, when we talk about primary assets, we are talking about a lifetime of 30 or 40 years. When we have a look into the secondary applications or control, we're talking about lifetimes of 15 or 20 years. So it's really a challenge to make here recommissionings and make these as smart as possible. The primary assets are still tested. Here it's really important to do this primary injection to verify everything on the also on the control level. But the primary asset itself, a transformer or an current transformer, voltage transformer, overhead lines, these assets have to perform all their lifetime. So with, the testing will not change. Of course, monitoring will increase here.
Okay, because of the time frame, it's much longer than previous.
Yeah.
Okay.
Yeah. And what we see, and as I mentioned before, we see here the control technology, which is important. And this need also to be tested and verified.
Florian, do you have any particular examples of how the industry is making adjustments in this area?
Okay. One example, what you see here is that the industry is making the distribution grid more smarter. And one key element is the secondary distribution substations or ringman units, which are installed in deliveries, the power to the households or the smaller industries. And as I said before, here the grid was more or less passive and just distributing the energy. And we have here now the prosumers. This is, of course, now a relevant topic where new technology is installed. So we see here sensors coming in, and we see here also sometimes now protection is coming in, and a lot of smart things, fault locators, making these values we have here, so the load flow values, voltages, currents available, and sending these to the local control center for two different things. So one is that the control center, in case of a fault in the network, can switch the cables or overhead lines. And on the other hand, we have here also that the utility gets better an overview about voltage drops or even over voltages due to high solar injection, or doing the planning here. So what is the load of the cable? What's the load of the transformer? And recognized what they have to invest in the upcoming years. As you can imagine, these investments need to be planned, and it's not that easy to do this with all the consumers, which are not that easy to calculate.
Florian, what makes distribution substations smart?
Mm-hmm. That's not that easy to say, but of course the control technology which is coming makes it much more smarter. So we see our protection relays, fault locators, and RTUs are getting more and more digitalized and getting more and more functionality. And making not only the measurements, but forwarding this data to SCADA and control, and make decisions on these data we are generating, is making the substation itself smart. Digitalization behind.
What are some of the specific ways OMICRON is doing to help power system engineers to master these challenges?
So we heard now a lot about new technologies are coming to the grid, and these are all stuff the technician and engineers need to care about. And we like to make everything possible in case of measuring or monitoring. But on the other hand, we would like to, or we are doing to reduce complexity. So that's a typical engineer and technician can also handle these measurements. On the other hand, we would like to do our tools small and lightweight, to make a small footstep, to carry these stuff around, and even to make it lightweight for our customers. Third thing is we are famous for our multifunctional devices, so that you don't need multiple devices carrying around with different software interactions. So our goal is to use a low number of devices. And the fourth thing is we try to digitalize it. And this was, for example, a good thing in the Corona crisis where we had all the shutdowns, that also from remote, for example, an engineer could assist a technician on site with our tools, which are mostly interact with a PC. This is possible.
Can you describe some of the ways we're reducing complexity in diagnostic testing?
So we try to make it from a user experience point of view fitting for the application. So we do a lot of research together with our customer, asking them what is their application and what is the detailed measurement or diagnostic you would like to do. And going really on the point. Don't make too many options available, and design it really for the application, that the customer can really make it forward. Of course, it's not always easy because we are in a complex world. For example, partial discharge measurements or protection testing that's going in the comprehensive way. It's really very complex applications, and usability starts to make everything available for the customer he want to do, but we try to make it on the point.
And could you describe some of the ways we are digitizing our solutions?
So mostly all of our test sets can interact with the PC. And having the PC available is also one step into the digital world, where, for example, somebody over a tool like TeamViewer can have a remote look on the measurements. So that's one good example. But we have also interaction with the PC when there is no direct control from a PC is available. For example, for Compano 100, we have the possibility to store sequences and results to an USB stick and make the testing even here more simple, and the reporting afterwards also digital on the digital way.
Florian, to summarize, what can power system engineers be doing now to best prepare for future challenges?
Yeah, I think keep on learning and accept the challenges. So I think it will come into very interesting years here with a lot of changes, and that's very interesting. Be brave and try the new ways, and also encourage other to try these new ways. I think that's a very interesting area we're currently living and working at. As I said before, a lot of control or a lot of monitoring and digitalization is coming. And of course, this is a challenging task creates new tasks. But on the other hand, it helps us to automate a lot of things to create time for the more important stuff. And I think we need to think a little bit out of the box, having a different look on topics than the past years. It's always good to learn, sharing the experience when you did positive experience, but of course also when you did some negative experience. That's the most we can learn from, and sharing here the knowledge to other utilities, to other colleagues is very helping us in driving all the changes we are seeing in front of us. In the future.
Florian, where can our listeners learn more about the future of power system testing?
So in principle, here we are from OMICRON having different channels available. We are very active at YouTube. We have there a lot of videos available where you can have a look. We have our customer areas. We have a lot of application notes there. I would like to encourage you to have a look there. We have different kinds of events, depending also digital events where you can participate and interact with us. And we have also the OMICRON Academy, where we, of course, also like to share knowledge. And also here we have a digital format available where you can connect remotely.
Florian, thank you very much for taking the time to talk with us about the challenges facing power grids and what is being done to master them.
You're welcome, Scott.
And a big thank you to our audience for listening to this episode of Energy Talks. We always welcome your questions and feedback. Simply send us an email to podcast@omicronenergy.com. OMICRON has several years of experience in power system testing and offers you the matching solution for your application. For more information about our testing solutions, as well as online courses and webinars offered by OMICRON Academy, please visit our website at omicronenergy.com. Please join us to listen to the next episode of Energy Talks. Goodbye for now, everyone.